rocks are there in different period, and some of the caldera craters. These are the craters, and so this is the calderas, and it is stores after a depression is created, then store some rainwater. So it is look like some lake is there. So these are all the volcanic activities landforms. Then we look into the fluvial landforms. So fluvial landform related to the water. So it is action of the running water, a river or stream, and a lot of landforms are created with the erosion, transportation, and depositions. So fluvial landforms may be V-shaped valleys, deep valleys with narrow floors formed by vertical erosion. Then gorges and canyon, very deep and narrow valleys with steep walls. Then waterfalls from where hard rock overlies soft rocks. Then potholes, circular depression, maybe you are found in the origin of the river site and on the rocky river is there. Then in the near the river, we can found some holes are there in the rocks. That is called the potholes. Then rapids when different rocks are there. Then when the water is coming through these rocks, then there is a um, obstacle is there. So this obstacle creates some uh, create some visualization like the whiteness of the waters, and the current is very high in this area, so it is called as rapid. And this is the turbulent flow of the waters. The entrance meander is just moving of the river in different S shape or different angle due to some geological patterns are there, or some depositional and erosional patterns are there. Then this is called meander. So first we just look into the V-shaped valleys. So this is the V-shaped valleys. It is looking like this. So most of the Himalayan mountains having the V-shaped valleys. So in the large mountain areas or in the hilly most heighted areas, we just see this type of valleys are there. So valleys generally this generally look like the U type valleys. Then after weathering in the both side of the uh, channels, then it create the V shape structures. Then it is finally create the V shape valleys. So it is the irregular features of the river in the upper side of the hilly terrain area. So this is the Himalayan areas. So these red patches are there. So these are the V shape valleys. Then we also found some gorges and canyons are there. So gorges, so there are very similar like the gorges and canyons, because both have the deep valleys and steep sides, both uh, due to some presence of the river, and they slightly different in the scale and characteristics. So generally gorges are narrow and steep and small scale. So these are not widely spread, but canyons are wide and deep and large scales. So this is the major difference between the gorge and canyon. So this is one of the example of the gorge. So it is very uh, present in the very minimal areas, but canyon it spread in the longitudinal ways, so in the very deep also as compared to gorge. This is the canyon, and some of the differences generally narrow in width, and it is wide, much wider in canyon. Depth also it is as compared to canyon is high, and gorge is nearly formed by river down coating in the hard rock areas. So if there is some soft rock behind some hard rock, then it can erode all these soft rocks, then create some gorges. and it is also in canyon also formed by the erosion of the platform, or in tectonic tectonic uplift and weathering. And gorge is small scale and it is large scale in canyon. So some of the example of the gorge is in the France, and Tiger Leaping Gorge in China, and canyon is, that is the Grand Canyon in USA. So it is up to 1 to 1.5 kilometer depth is there, and Fish River Canyon in Namibia and Calca Canyon in Peru. So these are the famous canyon you can see in the satellite image also. Then waterfall. So generally, how this waterfall is created. So there are two type of rocks are present in the river beds when river flow through the different areas, or in the upper areas of the landform. Then there is some hard rock is there and some soft rock is there. So as the hard rock is more resistant to the erosion, so it cannot, the river cannot erode this hard rock, but the soft rock can be eroded gradually. So this is the process. The soft rock erode these areas. After a long time, it creates some long spool or undercutting. After that, it creates some large waterfalls. So this is the process. That means in this picture, the upper area is the hard rock and the lower area is the soft rock. So after erosion, then it creates a waterfall. So based on the heights, the waterfall is measuring the different in how much the waterfall is big, or how much the height of the waterfall. So now the Borepani waterfall is, this photograph shows the Borepani waterfall of Moyurbhanj, Odisha, in the Similipal Reserve Forest. It is the second highest waterfall in the India, having the height of 399 meters, and the highest waterfall in the India is Kunchikal waterfall. I think it is found in the uh, Karnataka area. And Nokkali Kai, that is the, I think it is in Manipur. So this is 340 meters, and the highest waterfall is 455 meters. So we can also see, this is the satellite view of the waterfall. So we can see all this waterfall in the satellite image. So it looks like this. So this is the waterfall, and this is the river of the Budhabalong in the Odisha. So just check. Just a second. Check one of the waterfall, how it is looking like in the satellite image. This is one of the waterfall which is present in the Manipur. So this is the hard rock which is present in these areas, and this is the hard rock. This area, it is showing these patches of the, it is horizontally present. This is the hard rock present in the upper area, and this area below these areas are soft rock. So this water bodies, as the upper area, there is a high velocity of the river, so it erode gradually these areas and create some depressions, and after creation of, after long time of erosions, then the waterfall is created. So if we look like, just observe The surrounding areas, the rock is very soft rock is present, and in the upper area there is a hard rock. There is a there is a boundary is seen in this area. इसमें दिखाई दे रहा है कि ये ब्लैक और व्हाइट इसमें जो डिफरेंस दिखाई दे रहा है. So it is the boundary of the hard rock and soft rock. So it is clearly visible in these areas. So it is also called as a tableland. It is flat land in the upper areas, and these are the valleys.
What land, sir? Sorry, what land did you mention? It is also called.
What? Tableland, tableland.
You said
So if in a
tableland.
flat area, tableland. So if it is a flat area in the upper areas, so it is called as tableland. So these are the valley.
Here, water is visible. Here, water is visible in the the imagery, but sometimes there could be a dry waterfall also that it's seasonal.
Actually
So
in
in
Goa
that,
also Dudh waterfall also tried. Hmm. Okay, just what your question?
so sometimes it's very difficult for me at least to see which is highland and which is lowland from the satellite imagery.
Yes, yes.
For example, it is very difficult to distinguish from the top. So, is there any some easy way or trick, like for example, we can distinguish which is soft rock, which is uh, hard rock in a dry waterfall, for example, or in general?
Actually, in some of the areas, it is not visible because the vegetation is covered by this, and there is the boundary is not visible. But if you are in the field study, you can see some of the sites are there. So another site is there. One Boripani is there. I just show you. This is the second largest waterfall. So in this image, there is no visible boundary between the soft and hard rocks. So based on the different landscape and this is the hard rock. It is seen in the areas. So we can this river cannot erode beyond this depth. Otherwise, if it is a soft rock, then the depth will be very high. So it is not very high depth because of the hard rock. So from this area, this is the hard rock area. Then it is the soft rock area. So these areas, surrounding areas, are soft rock areas. So it is the boundary demarcation is difficult in satellite image because most of the satellite are very low resolutions. So in this area, it is a 50 centimeter resolution. After that, also because the soft rock is not present in a different layers, already eroded in these areas. So that's why the boundary is difficult. So likewise, the waterfalls are there. So if there is a large gap between if the hard rock is largely present and soft rock is very limited layer is present, then the waterfall height will be very less. If the soft rock is very deep, then it gradually eroded, then becomes the height of the waterfall will be increases. So based on the soft rock and hard rock combinations, associations, and the presence, the waterfall height will be decided. Then then this is the waterfall related thing. Then potholes are there. So potholes generally the eroded rocks, the eroded by the river. So generally, when the river flow through the upper areas, a lot of rocks are there in the ground. So when the rock, small boulders and small uh, ingredient parts are there. So in the river, there is a swirling currents is there. So it generally erode this rock areas in clockwise or anti-clockwise with the very long time. After that, these rocks are eroded. So these are called as potholes. So it is a erosional surface in the river area. Basically, it is found in the upper areas of the rivers, because in the lower area there is no rocks are found, only sand. Most of the sands are there. So you may be seen in the different sites in different areas. This type of holes are there. So because most of the time the circular patterns holes are there due to the uh, flow of the some sediments and some of the small stones are there in the river. That's why it is circular. Then repeats. So repeats generally when in the upper Ganga river in Rishikesh, there is some rafting. Rafting is very famous in Tista river and also in the Ganga river. So how rapids are forms? So when there is a flow of the rivers, suddenly its height is decreases, then some rock surface suddenly height increases. So this height difference creates the movement of the rivers. The current is very high. So during this the rapids are formed. So this is the pictures. There's a hard rock and soft rock. It is also the concept of hard rock, because when the less resistance rock is there, then erosion is present. So when the high resistance rock is there, there's no erosion. So it is like some steps level, some steps in the buildings. And that's why the movement of the water is different and the current is very high. So that's why it is look like this is the photograph of the rapids found in the upper Ganga river and also in Tista river. So lot of turbulence are also found in that rapids. So rapids can be identified with the help of the satellite image. So which area is the high rapid area or turbulence areas? So it reflects more because of this whiteness, because it is not a calm water; it is a turbulent water.
But water should give the same absorption, no? Whether it's turbulent or whether it's calm or still, it should give the in the hyperspectral image. It should give the same reflections, no?
No, hyperspectral, we can identify the turbulence because a lot of also if there is any sediment also and depth also. So based on the depth, the water color is different. So we can found this type of informations. So hyperspectral definitely helping for more analysis in these areas. But in satellite image, if there is a high resolution image is there, maybe it is uh, locate these is areas. So if it is a wide areas and it is a large area, then we can find. So let's see if it is found in our Ganga river or not.
So the white color of the water due to high turbulence that can be captured by optical image, like what we see.
Ye- So you can see this is also turbulent water. This area, you see, this is the turbulent water. So it is also you can see this is the letter is Rishikesh Ganga river rafting. So in this area the rafting is going on because of the turbulent of the water, and there is the rapids. See, as this is a high resolution, you can see this whiteness of this water, and some rocks are there, small rocks. Due to this, there is a rapid is formed. This is the rapid.
And my second question is, sir, that from the whiteness, can we understand the direction in which the river is flowing? For example, if you are given an image in which there is like turbulent water and you see that there is whiteness, like foamy appearance,
Yes.
can you identify the direction of flow?
Yes, direction of the river you can easily know due to the some rapid is there is the tail and head type of structure is there. Then some this type of ripples are also formed if in this type of ripples are there. Ripples also show sometimes the direction. But if you have a elevation informations, you can know the directions. So if as we have know this is the heighted area, so we definitely know this is the direction of these areas. And if there is a, some area is like this, so we cannot know what is the direction of the. If one part is seen in the satellite image, you cannot uh, just guess that which direction this river is going. So we have to check the synoptic view of the river, and if you have any local experience, then it is also good. And if any other associate things are there, so suppose this type of structures are there, then you can see that it is the direction of the river in the downwards, because this signifies this landform, or this island landform signifies after the flowing of the river the sharpness is like this. So when the water is flowing from down to upper areas, then this landform cannot be formed. It may be in the circular form. When it is downward, then it is very sharp. So in the upper area, they just check, this is in circular form. That means the river flowing along these directions. So in the toy part or the tail part, this type of sharpness is created. This is one of the significance we can know. So if it is the east, if this scene is present in our satellite image, then we can know this is the movement of the river. Okay. So a lot of things are there, so associated with the movement of direction of the river. So this is the rapids, and this is the interlocking spores. So it is generally uh, the different directions of or this type of lockings are there in the hilly terrain areas. So this is called the interlocking spores. So that means the alternate side of the valley in the upper course of the river, ridges of lands around which the river winds in its upper course. So there is a different direction. There is a ridge of the mountains is present. So in the it is found in the most of the time the Himalayan area is this type of ridges are found. So this is also a ridge. So in this area This is the ridge. Then it is, so this is the ridge. So it interlocking ridge is there. So this moment is this. So these are the interlocking ridge. So all lot of interlocking ridges are found in Himalayan areas because of the height, large height.
And will there be chances of river or sea in the interlocking spur?
Most
Means
of the
I guess
time in the
there
interlocking,
will be.
eh, but most of the time in the interlocking spores, maybe river is present, but sometimes we found that most of the seasonal river is found, and perennial river may be present or not. But in the monsoon season, all these interlocking spots have mm, some small river channels are found. Actually, a river generation, generating the river is from one point. So based on the uh, particular point, the river is born. And all interlocking river has not found any river because this is one of the interlocking. So we just found some settlement is there. So there is no any water bodies are present. So out of 10 or 5 areas, only this area has the water bodies. This is water bodies, but in this area there is no water bodies. So based on the origin, it is decided what is the present of the water or is not. But in the seasonal areas, monsoon areas in the western Ghat or eastern Ghat, so we can found the water bodies. Then some depositional landforms. So all these are some erosional landforms. Then the depositional landform is alluvial fan. So it is like the fan type deposit at the foot of the mountain. So when there is any feeder catchment is there or and river is there, so it gather all these sediments from the upper hilly terrain areas, then deposited in the lower areas, and it creates some fan-like structures. So it is called an alluvial fan. So why it is occurring? So sometimes the river loses its velocity due to sudden decrease in slope. So when the slope decreases, then it drops the sediment, uh, all the carrying from the upper areas, and over time the sediments spread out in the fan and cone-like shapes. So some of the sediments are alluvial, good for the agriculture. So the photograph, one of the photographs showing the different agriculture is found, and some have some other muddy structures are there. So when there is a steep catchment, then the alluvial fan will be in the circular pattern. When there is a gentle slope, then the alluvial fan will be some and this type of structure. So there the two type of shapes are also found based on their elevations and steepness. Then flood plains. So basically, plains are found near the river is because when there is a flood is occur in the upper areas, so it exceeds the river boundary and spread to the buffering areas in 500 meter or 1 kilometer buffer areas. So these create some different landscape, and this is called as floodplain. This is the river This is the river. Then this is the flood plain. This is the flood plain. So lot of features like Oxbow Lake, Meandersker, all these point where all these are present. Different erosional depositional structures are also present in the floodplain areas. So basically, we also found that if the river is 50 meter wide, then some of the time the flood plain is 2 to 3 kilometer in the buffer zones, and various landforms are created based on their depositions or erosions. So in the satellite image also, this is the black color is the satellite image showing the river. Then the greenery areas are the floodplain areas. So it very much useful for some agriculture practices. So in the floodplain, various landforms are there like levees, oxbow lakes, beck swamps, point bars. So levees are generally raised embankment along the river formed for coarse sediment deposit. So we'll go one by one. So levees, what is levees? So levees is the raised embankment along the river. So it is naturally occur by the rivers, and it is most of the time natural and sometimes artificials. So during the flood times, the river just deposits some sediments in the course of the river banks. So then after mm complete of the first flood, then second flood, then again create some sediments and deposit in the banks. So after 2 3 cycles, it creates some depositional surface. Then it is there some raised areas are there. So this is called the levees. So in this satellite image, in this photograph, it just show this is the levees around the river banks. So it's look like it is artificially created a embankment or a depositional uh, boundary, but it is naturally created by the river with the depositions of sediments. This is the natural levee. After many floods, it is look like this. Then point bars. So point bar is also a one depositional on the inner band of the meander. So this is the depositional areas. So this is the point bar, this A part. So when there is a point bar means some depositions of some sediments by the river in the uh, inner part of the river. Inner part means suppose this is the river movement, then this is the inner part and this is the outer part. So then this is like in the mm, this is a convex shape and this is a concave. In the concave shape, the point bar is deposited, and the opposite sides there is a cut bank or river cliff is there. So this is a cut bank. Some erosional surface are found. The B part is the erosional surface, and this A part is the point bar. This is look like this. This is also in the point bar. This is look like you also seen lot of time in the upper areas of the rivers. Then meander. So meander is the looping band of river due to lateral erosion and depositions, and this is the meandering of the river. This sinusoidal shapes is the meandering of the river due to some erosional and depositional formations. So in also we can also look in the different river. So meandering of the river generally found in the lower areas of the river mouth areas, because in the upper areas there is no type of deposition and erosion occur. So there is no found of the meander of the river. So suppose there is a Subonrekha river, so it is straight. So this is the meandering of the river. In the lower areas also largely meandering river. So this is the meandering, the last part, and this is one of the river. So this is also meandering a large in the upper areas, in the lower areas. Sorry. So in this part, meandering is very high. So based on the rock type and other deposition on erosional surface, meandering is dependent on this. So cause of the river meandering is various flow velocities, erosion on the outer bank, deposition on the inner bank, and helicoidal flow, that is water move in a spiral motions. So generally, what is the main combined action of the erosion and depositions? Outer band is erosion, that is cut bank, and inner band is deposition point bar. So it is the point bar, the inner bank, and outer bank is the cut bank, that is the erosion surface. So this is the meander wavelengths, the eroding bank, and this is the point bar. In this area, this is the point bar. This is the point bar areas, point bar areas. This is the point bar areas. Then Oxbow Lake. So Oxbow Lake is formed when meander are cut off. So suppose there is a meander is there. So suppose there is a yellow part is the depositions and the red part is the erosion. So this is the erosion gradually eroded. Then this shape is created. Then it creates some neck of land between meander and land. Then after sometimes it is cut off. Then this cut off is called as Oxbow Lake. So in this picture also you can show a lot of oxbow lakes are there. This is the oxbow lake. So how this is created, I just show you in the satellite image. So this is the one of the river found near the mouth of the near the coast areas. This is the flow of the river in 2011. So so gradually we see that it is cut off from the main route. So this is create some channel. Then gradually when the river is flowing these areas, then it create a deposit in these areas. So in this area some depositional surface are created, and in these areas also some deposition of the sediments. After some times it is from the main river land, river flow areas. So you can see in 2025 there is a cutoff from these areas. So after sometimes it is totally cut off from these areas and create oxbow lakes. So it is recently created, so it is not clearly cut off, but these areas, this is the signature. So nowadays it is cut off from the main river. So this is the previous paleo channel. This is the old channel of the river. So now it is converted to the uh, aquaculture. So in this way, we can also see that this is one of the impressions of the previous of the river. This is showing. So these are called the paleo channels, and if there is a water is contained in these areas, then it is called as oxbow lake. It is also seen that this is the channel. This is the paleo channels is found. The likewise creates different oxbow lake and different paleo channels, and then create different path. So if we found that this is a present river shape, so after some 100 years or 50 years, then it cut off from the main channel and it connected to this from directly, and it is created some oxbow lakes. So in the lower areas, most of the time a river changes its course due to some different factors is there. Then deltas, and this is the depositional surface, and it is near the mouth of the river and near the coast. So delta is the made of deposited sediment at the mouth of the river when it is entered in the ocean, sea, or estuary or lake. So it is named after the Greek letter delta because of its triangular, mostly in the triangular shapes. And condition favorable for delta formation is large sediment supply from the river, gentle slope at the river mouth, and because the slope is very low, and low tidal actions and low wave energy at the coast. If tidal action is very low, wave is energy is very in the coast, then it creates some deltas. So based on the different landscapes, different shape of deltas are created. There is arcuate delta, Bart's foot delta, Cusped delta, Cusped delta, that is an inland deltas. So arcuate delta is that is fan shaped smooth coastline. Example is Nile delta, Egypt. Then Bart's foot delta, it's look like the Bart's foot, distributed projected outwards like Bart's toys. And Cusped delta, that is pointed projection from wave or strong. And estuarine delta form somewhat river valleys. So just look some of the deltas. This is the Arcuate delta in Nile delta, Egypt, in the Nile river. Then second is the Barfoot delta in the Mississippi delta, that is in the USA. So it is look like the Barfoot. Then there is the Cusped delta, that is in the France, and then Estuarine delta, that is in the Bhitarkanika also found. Then estuaries, and a lot of the estuary is generally the mouth of the river. So when the river meets with the ocean or sea, so it creates some different landform. So it is called as estuary. So when the estuaries are formed, that is based on the sea level rise, glacier melting, tectonic subsidence, barrier formations, strong tides, and wave actions. So various estuaries are there in the glacier area also, and in the coastal areas of the uh, lowland areas also. Then some of the aeolian landforms. So there are two type of aeolian landforms are there. So based on the sand deposits and some erosional landforms are also there. So some erosional aeolian landforms basically found in the desert areas. That is the blowouts and desert pavements, mushroom rocks, yardungs. These are the erosional landform. Then some depositional aeolian landforms is sand dune, lavas, ripple marks. So these are the pictures of some depositional landform. And some glacial landform that is created by the action of glacier through a process of erosion, transportations, and deposition of ice and glacier debris. So some of the example of the erosional landform and by the glacier areas, it is Cirque, Erit, Coal, Horn, Yusef valleys, Hanging valleys, Rods, mountains, and groups. These are the erosional landforms. Then depositional landform, that is like moraines. So a lot of moraines are there: lateral moraines, medial moraines, terminal moraines, ground moraines. Then drum lines, then eskers, cames, outwash plains, erratics. So this all are there. This is some of the pictures of the some erosional pictures of glaciers and some depositional pictures of glaciers. Then after then coastal landforms. So coastal landform is very dynamic and very frequently changes its landforms, and lot of erosional and depositional coastal landforms are like some erosional are like cliff, wave cut, sea wave, arches and stack, stomp, headline and bay. Depositionals are like beach. So you mostly seen the beach is only depositional landform. Speeds are there, so narrow ridge of sands, bar ridge of sands also, tombolo that is connected with some land part, then barrier island is there, then delta also, and then estuaries. So these are all depositional landform. So all lot of other landforms of coastal areas are also found. So this is the speed. So speed is generally connected one sand areas with some mainland areas. This is the speed bay mouth, barrier island, so it is parallel to the beach. And some tombolo that is connected with the island is connected with the mainland, this is called tombolo. Then these are the in the rocky areas in the western area. We can found some sea caves, sea arc, and sea stack, headland, and some beaches. Sea cliffs are also there. So sea cliffs are not found in the eastern coastal areas because there is not much of rocky mountains. So this is the basics of some offshore, near shore, shore, foreshore, and backshore areas. So in the low tide shoreline area, that is called as foreshore areas, and below the low tide breaker area, when the wave bar breaks, this is called as the near shore, and below these breakers, that is called offshores. So these are the based on their wave patterns and some on low tide and high tide tidal influence water bodies. Then we will see land use and land cover classifications. What is land use and land cover? So land cover generally includes the physical and biological cover of earth surface, and land use is the term describes so earth surface used for different commercial, social, and economic purpose. So land cover generally comprises of forest, grassland, water bodies, river, lakes, and sea. And land use generally recognizes agricultural land, paddy field, plantation, settlement, residual residential areas, industry areas. So basically man-made features are land use, and the mm, natural features present in the earth surface, that is land. So this is the different. So we have to calculate all these land use land cover based on the presence of the different landforms. So different classifications are there. Forest areas, lot of classifications are there. Residentials also. For forest, there is a reserve forest, urban, then degraded forest, scrub forest, uh, protected forest. So different classifications from land use classes we can use. Likewise, some agriculture, industries, commercial, and residential. All these patterns are there. So why we use the land use land cover classifications? So for different planning and different base map creations, we use the land use land cover planning, and for the growth and development, and shows the urban growth and how this is changes in every times. What is the land use pattern? So different bands having different categories of land use, like built up areas have different reflectance, farmland has different reflectance, then lake, water bodies, sea have different reflectance. So different land use class have different reflectance in the satellite image, so we can find out based on the reflectance. This is the one of the high resolution satellite image of the wild view 2, and it basically in the urban areas, urban planning and urban classification, we use the world view 1, world view 2, GOI 1 satellite images. So this is one of the example of some satellite image. Then you can also download some of the sample data from this. Is these are the satellite image of high resolution satellite. You can download from this link is there. From this link you can download. Suppose I just give you a example. So you can download some of the sample data for personal the use or practices of how this data is look like. So suppose there is a sport world view 3 is not downloadable. IRS-P6 SkySat is there, so you can download this data. Different type of sample data is there. So this is 1 GB data. Panchromatic sample data is a panchromatic sample data. So this can be downloaded. So just give you in the comment section, just in the chat box. Just save it and try for and download these files for practicing and analyzing these data. So all these details are also given in these areas. So what is the resolution? This is 5 meter special resolutions and how much bands are there. So all these are given. You can download some sample data because it is a commercial satellite image. So we cannot download the user defines locations. Then level of classifications. So there, so based on the scales, there are 4 level of classifications of land use. Suppose there is a forest areas. So if there is a large scale map, in the large scale there is only forest can be classified. Then level 2 in the 2,50,000. Then the what is the forest used for, or there is a protected forest or reserve forest, you can classify. So suppose there is an example I can give you. There is suppose 1 is to 1 million scale, that is a built up land, and in 2,50,000 it can be distinguished between the built up land and rural area and urban areas. So in 2,50,000 scale, it is the urban areas. Then we can in the level 3 classification, that is 1 is to 50,000, 50,000 or 25,000. So whether it's urban areas, residential, commercial, industrial, recreational. Then in the level 4, it is 10,000 scale. So it is a single storage, multi-storage, temporal shade. It can be classified. So basically, why use 1 million? Why we don't use uh, 1 is to 10,000? Because the presence of the satellite image, how the resolution is very high, then you can use the level 4 up to level 4 resolutions. So we cannot identify single storage, multi storage in the 1 is to 50,000 scale or in the 30-meter resolution data. That's why for the overall classifications, we can use different satellite images. So for high resolution, we can classify up to level 4, and for low resolution, we can classify up to level 2. So the resolution play a more important role for land use land cover classification. So 1 is to 1 million means it is a very small scale map, and 1 is to 10,000 means it is a very large scale map, because it is a ratio is very less. So these are the some level, um, 1 to 4 level of classification for each categories, like forest, wetland, water bodies. So in the forest, like forest biome, then evergreen forest, dense forest, then in 1 is to 10,000 oak, teak, or which type of species is there. This type of classifications based on the available of satellite image resolutions. Then scale of map. So generally, what is the scale of the map? That is the distance between the object in the map and same object distance in the ground. What is the ratio? So ratio of distance between the map to the distance between the object in the ground. So this is the scale. So map distance by ground distance. If there is a 2 centimeter in the map between the two object, and it is the 2 kilometer in the ground, then 2 centimeter divided by 2 into 10 lakh centimeters. So 1 kilometer is, I think, 10 lakh. So different resolutions are there. For 1 is to 2500, 1.25 resolution data is required. For mapping of 1 is to 10,000 scales, we need 5 meter spatial resolution data, and for 1 is to 50,000 scale mapping, at least we need 25 meter spatial resolutions data. So in Sentinel 2 data, which is 10-meter resolution, we can map land to land cover up to 1 is to 24,000 or 25,000 scales, but we cannot uh, identify in 1 is to 10,000 scale. So based on the resolutions, we can classify the different scale of map. So suppose one of the example is there. Suppose there is a map scale of 1 is to 2 lakhs. Given map have the distance of 3 centimeters. Then what is in the ground distance? So it's a required is the equivalent distance on the ground. So that is 1 is to 2 lakh into 3 into x. So x is to x is equal to 6 lakh centimeter. That is 6 kilometer on the ground. So 3 centimeter is in the map is 6 kilometer on the ground in the 1 is to 2 lakh scale. So if the scale is reduced, or scale is very high, I think in 1 is to 20,000, then the ground distance also decreases. Then minimum mappable unit. So if there is a 30 meter into 30 meter resolutions of satellite image, then we cannot map the data having 10 meter into 10 meter features in the ground. So minimum mappable unit is there. Generally we can find that 3 into 3 pixels. Suppose there is a 10 meter spatial resolution of satellite image of 10 meter into 10 meter. So we can easily identify minimum 3 into 10 into 3 into 10, that is uh, 30 into 30, uh, 3 into 3 pixel, 3 into 10, 30 into 30, so 900, sorry, 9 pixels are 3 into 3 means 9 pixels are identified. Suppose there is an example is there. Suppose the satellite data used for mapping having resolution 25 meter, and group of 3 into 3 pixel will be equivalent to 75 into 75, that is 5625 square meters. So converting into hectare, it is suggest 0.56 0.56 hectare is the minimum size. So suppose there is a satellite image of 10 meter resolution, then we can map three times of the just multiply the 3 into 3, that is 9 pixels. So each 9 So total group of the 9 pixel can be mapped. So in the Landsat satellite image, if there is a 30-meter resolution, then minimum mappable unit is 0.1 hectare or 100 square meter. So likewise, different examples are given in this. So what is the mappable unit? So based on the satellite image resolutions, the mappable unit, if there is a high resolution data, then mappable unit will be increases. And if it is a low resolution data, then mappable unit is decreases because we cannot see these features in the low resolution data. So this is the we can generally use the 9 pixel format or 25 pixel format. This is the diverse of LULC, proximity, urbanizations, and economic factors. So different models are used for the classification of land use. So we have also seen that some supervised classifications, unsupervised classifications are seen. So nowadays, artificial neural network, Markov chain, cellular automata, these type of models are used for uh, classification of the land use land cover. Then random forest model also very much useful. So we also see seen in the R programming and this random forest model. Then deep learning model also used for the different classifications. This is one of the example of the random forest model used in the Google Earth engines, having the different cloud data and having some training data. So this is the output of the random forest classification. So this is the one of the LULC classification using deep learning, and after the classifications, that this is the output of the different classes of the urban areas. So this is the technique, and so a lot of techniques are used for classification of land use and land covers. So this is about the land use and land cover, and we'll see different other application in the volcanic landforms are there. Then we'll see the practical session using the QGIS. Okay, so today we'll conclude this. So any doubt, just ask me.
Sir, I have a question. What is the difference between the catchment area and the floodplain you mentioned? Normally we
Catchment
come
area
across
or
catchment area when it comes to
yes, yes,
floodplain.
yes, and floodplain. Acha. Catchment
Floodplain.
area is generally. Acha. Tell me. So generally, catchment area is suppose one river is there. So in from which area total contributed all the drainage pattern. Suppose there is a so it is the coastal area. So we cannot see this. Uh, so suppose there is a landscape. This is the river. So catchment area generally we can find out. So from which areas or from which direction all the drainage pattern are connected to this river, and all these are fall within this river. So suppose this is a river. So from these areas, I have to identify the catchment area. Then these are the drainage patterns. So these are the drainage patterns. These are all connected with this river. So the catchment area will be these areas. So this is related to the how much drainage are connected to the particular river at that point. So this is the catchment areas, but the flood plain area is different. how, if there is a general normal river is flowing in the particular area, and after flooding or after flooding, after the overflow of the water bodies from the river, how these water bodies can be spread both of the directions of the river in the buffer zones. So the spreading of the water bodies during the flood timing, so this create some plane, or this create a temporary plane. If it is frequently occur, then it create a natural different dynamic structures. So this is called as flood plane. So this is I think in the this area you can see this is the river of the uh, Budhavalong River. So this is the floodplain areas. So these are the floodplain areas. So this the signature of some paleo channels and some different direction of the rivers. So pastly these are the signature of the rivers. So the floodplain area is like this. So generally it is the uh, buffering areas of the rivers, but catchment area is different. In the catchment area there is no buffering areas. How the water is collect how the river is collected all this water, all these waters from different directions. So कहाँ से जनरली अगर रिवर है इस पॉइंट में कौन से जगह से वो रिवर कलेक्ट करता है डिफरेंट ड्रेनेज से, जो फीडिंग पॉइंट्स ऑफ द रिवर्स। सो जितना भी फीडिंग पॉइंट्स है, अगर इसको कनेक्ट करके एक पॉलीगन बना देते हैं, दैट इज कॉल्ड कैचमेंट एरियाज। ओके।
Thank you, sir. And the second question is, when you mentioned that SkySat is commercial satellite image and we will get a 5 meter spatial resolution, so I could not get the transition between that part of the lecture and the table what you showed regarding that levels and the different land. I think maybe because of my internet, I'm I'm on the train, so
Okay,
the
okay.
internet got
Actually,
disrupted. But I could not.
I just no, no. Actually, I just give you some link that some of the sample data you can download from the satellite and the sites, and you can just check different bands and different. Yeah. So this is the just link I just given. But in the land use it is different. So in the land use land cover classifications, you can also download this sample data and classify all these land use land cover classify based on the using of the Python software or any R software or any GIS softwares. So because high resolution data cannot be available freely, so you can download this sample data and use different methods for classification of the land use. Because in the low satellite images, the land use pattern cannot be distinguished easily. And in the last class, I will give you some links and how to download some satellite image.
So the table that you
Okay.
showed that different scales have different. Uh, hello.
Yes, yes. Table.
Yeah, so the table that you showed before that, you were showing how the different landforms can be distinguished. Yeah, I think afterwards, after that, slide, different landforms can be distinguished in use.
Landform. There is no landform distinguishing.
Hello.
Huh? Which slide?
So
Hello.
after that, yeah, after that, there was one slide in which So there was one slide in which you showed one table.
Okay, one table.
Uh, so,
Okay, tell me.
so different landforms could be identified. Yeah, I think it was this one. So
Okay, okay.
the
Mhm.
SkySat, so the SkySat website will give us different levels, I suppose, right? The different levels of
Data.
images. The
Acha,
SkySat
sky
will
say.
will practically where will we get different levels
It is not
for
written in
practically?
any different level. So based on the presence of the spatial resolution, so we have some compulsory. We cannot go beyond this, because suppose there is a high resolution data, we can create some 10,000 scale or 5,000 scale mapping. It is a very high resolution. But in the 30 meter, we cannot analyze all this. What is the residential or commercial buildings? But in the world view data, we can identify because of the high resolution and buildings are clearly visible. So that's why we just differentiate in this corresponding resolution data and map. So this is the if there is the this is the resolutions of your satellite image, then the map scale may be present in this zone. So this if your resolution is 12 10 to 12 meter of the pixels, then your scale will be 1 is to 24,000, because in 1 is to 2 2,500 cannot be seen. So this is the large scale map, and this is useful for cadastral mapping. So the presence of the resolutions we can see in the different slides how this is created different land use. Okay.
Sir, when you said that uh, with low resolution, the minimum mappable unit decreases, what was why is that? With high resolution, MMU increases. Can you please explain that?
Suppose I think there is a uh, uh, 20 meter into 20 meter one area is there, 20 meter into 20 meter. So if our satellite data is suppose Landsat 5, so our Landsat 5 resolution is 30 meter. So when we detect this one pixel having 30 meter into 30 meter resolution, this 20 meter into 20 meter areas, it cannot be possible, because our pixel itself is 30 meter. So how can it is possible to map this 20 meter into 20 meter dimension of the one pictures? So for this, we can maybe calculate with the help of 5 meter into 5 meter, because in the 5 meter into 5 meter there are four pixels are having, and in the fourth pixel that is 20 into 20. So if there is a 1 meter resolution data, then there are how many pixels are there? The 20 pixels in the row and 20 pixel in the uh, column. So in the particular 20 meter dimension features, if there is a more pixels
Got
of our satellite image,
yeah.
then we can get it. Okay, so we can
Thank you.
see this in the next slides. These are the some land use classifications. So in the this is the false color image. These are the land use classification. I will give you all this land use and cover manual, so which is also received from ISRO. So this is the standard land use and cover classification prepared by the ISRO, that is NRSC Hyderabad. Then you can just see and just check, and you can also work on that. So a lot of features are there. how this is classified, and it is also described. So in the next class, I will give you all these slides. This is the mangrove, and this is the grazing land. How the grazing land is different. How this is dense cropland is there. So these are all the list for database informations are there. How these different features are look like in the satellite image. So just basic idea how they classifies. This is the urban area and this is the barren rocky land because there is no vegetations. If there is a vegetation, then it's look like the red color. That's why it is barren rocky land. There is no trees are there. So likewise, you can just you can know more about these features. So this is about the land cover. Okay.
Excuse me, sir.
Okay.
Sir,
Bolo.
I want to ask, along with this slide, can we also get the previous slide of MGY 005 and 006, if possible, sir?
Okay, okay. I will send you all these slides tomorrow or day after tomorrow because on rest there are two class are there. So in between I will send you all these slides. Okay, no problem.
Okay, sir. Thank you, sir.
Okay, okay, okay.
So
सर एक
tomorrow we have
छोटा सा
class.
क्वेश्चन था
हाँ बोले.
सर, ये जो आपने लेवीज के बारे में बताया था कि वो फ्रीक्वेंट फ्लडिंग से वो बनते हैं नदी के पास,
हाँ हाँ हाँ.
तो सर मतलब ये एज अ थंब रूल हम यूज कर सकते हैं क्या कि जहाँ पे वो स्ट्रक्चर फॉर्म हुआ है वहाँ पे मतलब वो फ्लड प्रोन एरिया है, या ऐसा हो जरूरी नहीं है?
नहीं, फ्लड प्लोन एरिया तो डिपेंड करता है कि आपका मतलब सपोज 50 या 100-200 ईयर्स में ज़्यादा फ्लड होता होगा, उसके बाद एक लेवी क्रिएट हो गया होगा. बट अभी फ्लड नहीं है बिकॉज लॉट ऑफ रिवर हैव नॉट सफिशिएंट वाटर्स एंड ड्रेनेज पैटर्न. तो हर जगह ऐसा नहीं हो सकता. प्रीवियसली देर मस्ट बी ए फ्लड, but presently not possible all these areas.
ओके सर, थैंक यू।
Thank you.
So do we have class tomorrow?
Yes, tomorrow also class is in 6:30 and day after tomorrow there is 6:30. So rest there are two classes there. So do you have any problem tomorrow?
Because
Because
tomorrow is
there is a puja.
no, no problem. Just confirming because tomorrow it is Ganesh Chaturthi, so just wanted to confirm
Yes, yes, yes.
whether we
I
have
just
holiday or
actually there is a holidays, but in 6:30 we can.
No, no, the morning is
Uh,
the puja only, sir. Evening we are free, no? We can continue. Sir.
okay, 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 okay. So Manpreet, is there any doubt?
No, sir. Thank you so much.
Thank you. Okay, then we will just conclude this session. Thank you. Good night.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.
thank you.